I'd love for you to give a quick, brief overview of what the state connector actually is.
So the state connector is a method for proving data from other blockchains onto Flare. So an example from the F asset protocol is that a minter of F assets has sent, let's say, their Bitcoin or their XRP to an agent that is in the F asset protocol. So we need to be able to prove that that has happened. And then on the other side, we need to be able to prove that the agent has honored a redemption of an F asset on the underlying chain, let's say Bitcoin or XRP. So those proofs are they come through the state connector. And the way the state connector works is that there's essentially what we call a default set of attestation providers, and this comes from the validators. And then there's what we call independent attestation providers. And this is where we get into a slightly complex thing called the forking protocol, which is can happen when an independent attestation provider deviates from the default set. And this is to make sure that the default set, and essentially, if they become malicious at any point, that there's a way to essentially recover the network and make sure that there's no loss of funds related to the state connector.
Yeah, and it can also be used to from other networks to sort of observe transactions and then execute something on Flare, because I believe we've got Dirk from Expector in the house, and there was a recent demo where an NFT was minted, an Expector versus NFT was minted, and it was bought using Dogecoin but minted on Flare.
Absolutely, and I think this creates an economic model whereby, let's say you want to do a token for rewarding something that is happening across multiple chains. Let's say you wanted to do a token that is perhaps rewarding something, let's say bandwidth providers in Layer Cake, right? That's just a theoretical example. Let's say you wanted to reward people who bridged through Layer Cake, who are bridging across multiple chains. You don't necessarily have the data of actually what's happening on each chain. It would be very hard to create that reward in like 10 different places. But the state connector allows you to basically bring all that data about what's happening in those multiple systems to one place, to input that to a smart contract, to assign an NFT, or to assign a reward token or a governance token or whatever that might be.
Thanks for a short introduction to the protocols. And yeah, let's dive in the demo. So I'm Philip, and today we'll see how we can bridge external information from external chains directly to the Flare ecosystem and see what we can do with this. So we're going to mint an NFT on Flare ecosystem, specifically on Songbird chain. Songbird is Flare's canary network. And we're going to do this by paying on external chain and using the state connector to prove that those payments really happened. And most importantly, proving this in a decentralized way without trusting any specific oracle for this bridging. So let's take a quick walkthrough. So we're going to be bridging information from external chains to Flare and Songbird. And to do this, we're going to be using the NFT demo app that is currently live on Songbird. And the first thing we're going to do, we're going to open the dApp. We're going to select the preferred token in which we want to pay. And the dApp is going to query the FTSO system. And the FTSO system will respond with a specific price so that we can price the NFT in Doge on the XRP ledger without having to rely on some oracle to provide us this price. And once we know this, we can reserve our NFT. This is essentially just a contract call on the Songbird network to reserve, to make a reservation and get some additional data. And our contract, the NFT contract, will respond with the data that we require to proceed with the payment. So the amount we need to pay, the payment address, and the reference we should include so that we can identify the payment with a specific NFT. And once we make this payment, importantly, we make this payment outside of the Flare ecosystem. We make this payment on an external chain, and the state connector is able to attest to this. And once we do it, we essentially have to gather all the information about the data. We need to wait for the payment to complete an external blockchain, so for the external blockchain to confirm it. We then provide this data via our local attestation client to the state connector, and the state connector starts the proving route. So the state connector emits an event, and now the default set of attestation clients, so this decentralized set that is proving things, then starts to request the things, gets the information, and then after specific intervals, pushes this directly to the chain and thus confirms that this specific transaction, or more generally, a specific batch of transaction really happened. Once this is done, we essentially just supply the information about the transaction on external chain to our NFT contract on Songbird. And this contract firstly checks that this transaction information we supply to the contract is correct. So we paid the correct amount, the correct address, and then uses the state connector to assert that this transaction really was confirmed by a decentralized set of attestation providers. So an important thing to stress here is the fact that all core operations during this data flow are essentially decentralized. So we are never relying on a specific data provider. We're never relying on a specific oracle, but the state connector and the FTSO system that are native to the Flare essentially rely on a set of providers to achieve a conclusion on what exactly happened. Okay, so let's see it in action. So we're going to mint this on Songbird. We're going to be using this demo dApp that is deployed there, and we can just start. So the first thing we need to do, this is a simple demo dApp. We need to connect our wallet. So as Hugo already said, Flare is an EVM compatible wallet. So any EVM compatible wallet would do. So you can use MetaMask, you can use anything, but in our case, we're going to use Bifrost wallet that natively supports Flare, and we're going to use the wallet connect to do this. So the first thing we need to do, we pick a currency, let's say Doge, and immediately the dApp queries the FTSO system, calculates the price, and this is a specific price for our NFT. And the last few digits are used to, once again, some sort of as a memo field to identify our NFT with the transaction we're making. So we make a reservation. Reservation is essentially just calling a contract to confirm that we want this NFT to be minted. We sign the transaction, we confirm it, and immediately after the transaction is signed, our NFT contract gives us back information about the payment we need to do. So the destination address we need to pay to, the reference we should include, and the amount that needs to be paid. Once again, the amount is calculated using the FTSO system. So the QR code is generated here, and we use any compatible wallet that can be used to make this payment. So we scan it, we check that the payment is correct, and we send. Okay, we pay, we sign the transaction, and away we go. So the payment is now done. So the Flare part is now done, and we've already paid everything else on the external chain. So we've moved the value on external chain, and now we need to transfer this to Flare. So the important thing to notice here is that the state connector is secure by default. So we never want to include the transaction that was not really confirmed on the network in the state connector, because that would be problematic from a security standpoint. So for our case, we'll need to wait quite a while to get this transaction confirmed. We're just going to use a transaction that we're sure has been confirmed on the Doge network. Apply it here, create a request. And now what we're doing now, we're essentially prepping our local attestation provider to get us all the data about the transaction, push this to the state connector, and prove it there. We create a request. This request is again an attestation, a request on Flare. And now we request an attestation from the state connector. So what we're doing, we're essentially querying the state connector saying, prove that this is the hash of this specific transaction sorted with some Flare specific data, and that it did happen on the Dogecoin network. We confirm this, we sign this transaction. And once the transaction is signed and confirmed by the network, the state connector kicks into action. So all the attestation clients in the default suite, the full set of decentralized attestation clients, has now received an event that this transaction should be proved in this specific attestation round, and they're now confirming it, they're now querying their own nodes to confirm it. So we need to wait for a while, and while we wait for the state connector to bridge this to Flare, let's just hop in on another version of this dApp and continue our purchase, but this time do it on the XRP network. So while we're waiting for the state connector to confirm the Doge part, we're just gonna buy another NFT on the XRP ledger. So again, we select the currency, and before doing anything, we should connect our wallet. Again, wallet connect, scan the QR code, connect to the network, and select XRP. So the price is different in XRP, but again, it's calculated using the FTSO system. So again, we're buying the NFT number 2, and we should pay at least 2.5 XRP on the XRP ledger. Again, we're going to reserve the token. Again, we're reserving token for the XRP, confirm, sign the transaction. And after the transaction is signed, the contract gives us back the things we need to prove. So we should send to this destination. The destination is obviously different because we're paying on a different chain with this reference and this specific amount. In this case, we don't even have to transfer to a new net. We're going to allow the Bifrost to connect directly to our DEP and make the transaction on the XRP ledger directly from the DEP. So again, query the XRP ledger. We're sending this transaction with this memo data to this address, confirm that it's correct, sign it, payment is sent. And now, again, as before, the payment is sent on the XRP ledger. And the only thing we need to do now is to prove that this transaction from the XRP ledger really happened and get this to the state connector. So what do? The transaction ID is automatically returned from the Bifrost wallet. We again create a request. We should attest that transaction like this happened. And again, we request an attestation from the state connector on Songbird. So again, we're saying, okay, we want you to prove this transaction and make it available to the network. We check that everything is correct. We confirm it. We sign it. And transaction is submitted. And now it's all in the hands of the state connector to collect this, choose it, commit it, reveal it, and finalize it. Now, if everything went smoothly, so we're back on the DOSH part. So the DOSH part has been paid, and we're waiting for it to be confirmed. So the state connector essentially works in rounds. So we're collecting the information we need to prove. We're choosing and committing the Merkle route referring to those transactions. Then the state connector attestation providers reveal this, and then they finally just finalize everything, that everything went smoothly. Although the NFTs we bought here were not that expensive, the state connector, through a decentralization and not having a stake in the system, is able to provide a secure and safe and decentralized information about transaction happening somewhere else for a transaction of a practically arbitrary value. So we're not limited by the stake in the state connector system. Okay, so let's check. We can already get a proof from our local attestation provider. And this is the proof that is essentially identifying our transaction and transferring this to our contract. So what is this proof? This is the proof that was generated by our attestation client and also submitted to the state connector. And essentially, it contains the full information about the transaction we did. So in which round was it confirmed, the hash of the transaction, attestation types, and most importantly, it contains the full information about the transaction. Why is this important? Because we're going to be putting this again back to our NFT contract, and the NFT contract can then check if this transaction confirms to the transaction that should be made to make a payment. So is the value high enough? Was the timing correct? Is the chain correct? Is there a correct memo field? And is the receiver's address correct? Okay, so the state connector has finalized. This is the proof we're sending to the contract. And it's now time to essentially query our contract one more time, this time with all the information about the transaction. So essentially, we're sending all the information, and the contract, which is just a simple program, can then send it. Okay, we confirm this, we sign it, and after the transaction is confirmed, bam, the NFT is minted. So the contract received the correct information. It checked that the transaction was coherent with the rules it set. And it also checked with the state connector that this transaction really was included in the proof made by the state connector. So this is our brand new NFT. We can also see it on Blockchain Explorer. And we can also take a look at our wallet when we can see that we have acquired a new multi-chain minted NFT. Okay, so the Doge part is done. And the only thing we need to do now is to return to the minting phase of the XRP ledger and also finish the transaction there. So the state connector has almost finished here. And again, we're going to do the same thing as with the Dogecoin. So we're going to get proof that uniquely identifies our transaction. So again, here we have a proof. Here's the round ID. It was included, the message integrity code, everything that the smart contract needs. So the important thing is this data is directly sent to the smart contract, which is just a program and can do any computation it wants. In our case, we're minting an NFT, but the possibilities are practically unlimited. We can execute a swap, we can liquidate something, we can move some funds, we can execute a time-locked contract call, we can claim things, we can even communicate with other blockchains through other bridges. Practically, the options are limited. The only thing that is important is the fact that information about this transaction having been done on an external network has been transferred in a decentralized way. So there are no steps during this minting process, during this execution process, during the trigger process, where we rely on a specific centralized entity to provide us with correct data, with up-to-date data, or at least provide us with some data. So we're always just kind of using the data as it were without having to worry about the penalization processes and stuff like this. Okay, so we just wait for a few seconds. And again, so we're sending this data directly to our NFT contract. And the only thing we need to do is to confirm this, sign the transaction, and once the transaction is done, our X-Spectre NFT is minted. So again, EVM compatible chain, all the computations can be done. And let's also see that one in Explorer. And yes, here it is. Let's see, we should also be able to see it in our wallet. And yes, we're the proud owner of a new NFT minted on Songbird using the power of decentralized information bridging by the state connector. And let's just check all the owners. And since I've minted with two different wallets, we can see that we have two different owners. The first one owning a Doge NFT and the second one owning an NFT paid by on the XRP chain.
Mission Control, we have liftoff.